Yeah, we are ready to start now. See, this is actually
Yeah.
basically this is the AC and ventilation system design training. Okay, as I said, uh, if you are in a consultancy field, okay, so if you are in a design company, something like that, since you are in supervision, but if you go to your design department, what they normally they do, there will be client XYZ client. Okay, so they want to construct a different type of projects, maybe a villa project, or maybe you can say residential tower, shopping mall, whatever the
Yeah.
projects. Okay, they have a bare land, right?
Yeah.
So based on the bare land, we are going to start the architecture team. We will start designing the project. Okay, there is a space planning called the space planning. Within the space,
Yeah.
whatever the space availability, they will start designing the projects. So, as I told you, one small example. Say for example, there is a plot. Okay, there is a plot something like this. This is a plot available from client. Okay.
Yeah.
Okay, now in this plot, the client want to construct one project. Okay, say for example, maybe he want to decide with a tower project. Okay, say
Okay.
what is a tower project. So what is architecture they will do normally? They will this is the plot limit. Okay, based on the plot limit, they will design maybe the below the plot limit. Maybe there is a basement or whatever the projects they want to plan. And say for example, this is the uh, footprint of the building. For example. Okay, so
Okay.
in the footprint of the building, they will start designing the setback area. Okay, basically, if you see my syllabus with the architectural design, understanding the architectural design, how the architectural space planning will be done. Okay, we are not going into the calculation directly. Okay,
Yeah. Yeah.
we are going to understand what is the space. So, fair. Say for example, if this is the building, okay, you have a car park area back in the outer side, or you have a landscaping area.
Mm-hmm.
Okay, and you have a roads. Okay, there is an entry, there is a exit, and also there is a building footprint. Inside the building, you have a say for example, you have a reception area, entrance area. Okay, then you have a say for example, in the ground floor, you have a say for example, there are some apartments or there is a lift area to go to the highest tower. Okay, then you have a
Okay.
staircases. Then you have a
Mm-hmm.
multiple plant rooms. Say for example, you have a electrical plant room, mechanical plant room. Then you have a tower. Okay, assume that you have a tower. So this is your tower. Okay, this is your lift area. Okay, and this is your lift area, and you have a staircase for
Okay.
example. Then inside there is a
Mm-hmm.
apartment or a commercial building. So inside the apartment you have a space planning. Okay, each and every space, what will be the minimum area. Okay, so whenever you design, say for example, you have a residential apartment, right? Inside the apartment, what is the size of the bedroom, what is the size of the kitchen, what is the size of the corridor, what will be the size of the
Yeah.
staircase. So everything has to be done by space planning, right? So the
Okay. Yeah.
very basically we will start learning the architectural design. How we will not go in much detail, but you will start reading. I will be sharing some documents. You will go through the documents, okay, to understand, and then we
Okay.
will have a
Mm.
discussion how what you understand to just brainstorming, right?
Oh. Okay. Yeah.
Okay, so you know the architectural how the architectural space planning is done. Okay, each and every room how they design. Say for example, if you have an electrical plant room, mechanical plant room,
Mm-hmm.
or you have a
Mm-hmm.
firefighting plant room. Then you have a car park area. If you have a basement, you have a car park area. So each and every car park, what is the space and what is the distance you have to provide. If you have a corridor, what is the distance? So that understanding we will get a basic idea. So that whenever you are working in a design department, you know the architecture how they develop. Because without basis, we cannot go to the calculation directly, right?
Okay. Yeah.
So this is my first module. Okay. Then the second module, we will understand the design codes,
Mm.
standards, guidance. Okay. Say for example, you have ASHRAE guidelines. Okay. So ASHRAE guideline,
Okay.
we understand what is the external temperatures. Basically, if you go to ASHRAE weather parameters, you have a coldest month, you have a hottest month, then you have a latitude, longitude. Okay. And we will
Yeah.
understand what is a dry bulb temperature, what is wet bulb temperature, what is specific humidity.
Mm.
Okay. What is enthalpy.
Mm-hmm.
Okay. And what is the U value. Okay, what is the external
Okay.
design temperature? What is the internal design temperature? Okay, what is the parameters to be considered when you do the calculations, right?
Okay. Yeah.
Okay,
Yeah.
so these
Mm.
are the things we will go through in model 2. Then after that, as a basics, okay, we will study little bit psychometrics, little bit thermodynamics, properties, okay, properties of the air,
Okay.
okay, heat transfer method. Then
Okay.
we will go. Actually, there are a lot of videos. I will be sharing you the video. Watch the video. Try to
Mm-hmm.
understand the basis. Okay.
Sure.
Then after that, we will go to the
Okay.
HAP thermal load calculations. Okay, HAP thermal load calculation is a HAP software. Okay, I'm not sure whether you have worked in HAP software before.
Actually, I worked before but the old version, not the new version.
Okay, see, actually, it is a old version or new version. Okay, we are not going into the type of software, but we are going to understand
Okay.
how the calculation is made. Okay, for example,
Okay. Yeah.
if you are using what software you have, 5.1 or 4.9?
Actually, I'm using 4.9 now.
Okay, 4.9 is okay for the engineering purpose. Okay, we are not operating in the app. That is a different purpose. But we are going to understand how the calculation is being made. Okay, say for example, here you
Okay.
have a 4.9 software. What you are going to do, you are going to enter the values, right? So
Yes.
whenever
Yes.
you enter the value, you should know that how they are calculating. What is the basis behind that? Say for example, whenever you get the result, you will get a result total load, total cooling load. You will get sensible load. You will get airflow rate. You will get chilled water temperature, on coil temperature, off coil temperature, coil bypass factor, right?
Yes. Yes.
So we
Yes.
are going to understand what is that each and every types. Okay, how say
Mhm.
for example how you get the total load. What is the meaning of total load? It is nothing but sensible load plus latent load, right?
Yes.
So
Yes.
you are going to calculate sensible load and latent load for each and every heat. Okay, there are heat from different applications. Say for example, the heat coming from light, the heat coming from human, the heat coming from
Yeah.
floor, the heat coming from roof, the heat coming from through the wall. So we are going to understand each and every basis. Okay, how that heat comes from. What is the equation to calculate? Okay, so after you
Okay.
calculate, whenever you see the HAP result, have you seen there is one table called total sensible load and total latent load, which is called the total load, right?
Yeah. 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 I understand.
So that each and every value how we were calculating, what is the basis, what is the formula behind that? That we will go through in model 5. Okay,
Okay. Yeah.
once you finish everything, the HAP thermal load calculation, then we are going into the fresh air calculation. Say for example, you have a building. Inside the building, you are going to cool, right? You are going to have a recirculation. But what will happen? Your indoor
Yes.
air quality, because if you keep on recirculating, what will happen? The indoor air quality, it will get polluted, or you have a contamination inside. So to remove the contamination,
Yes.
we are going to have a pressure calculation based on ASTRAE 62.2. We are going to have we will do the calculations. Okay, but when you do the calculation,
Okay.
can able to do the supplier calculation, supplier flow rate. Then you will
Mhm.
calculate exhaust air flow rate, right? Then after that, based on that, how
Yeah.
to
Yes.
calculate your what is the different type of FHUs, how you are going to calculate the capacity for FHUs, what is the formula behind that? And if you talk about
Okay.
FHU, I'm not sure that what size of the project you have worked, but if you work for tower project, very big projects, you will be having a very big
Yeah.
FHUs. Inside there are multiple components, like you have a thermal wheel, you have a cooling coil, then you will be having a sensible wheel, you have a thermal wheels, you have a horseshoe heat pipe, you have a heater, you have a humidifier, you have a dehumidifier. There are many parameters, many parts, right? So each and every part, how to
Yes. Yes.
calculate. Say for example, you might have seen sometime heater. So how to calculate the heater capacity? You might have
Okay.
seen sometime
Okay.
humidifier. How to calculate humidifier capacity? So these are the things we will go through in module 6. Okay. After that, we will
Okay.
go through the general ventilation. General ventilation is what whenever you have a building, you might have seen you
Mhm.
are working in some projects. You will have a generator room, you have a transformer room, you have a battery rooms, then you have a kitchen area. So how to do the general
Yes.
ventilation for these rooms? How to calculate airflow rate? How to calculate the fan capacity? Right?
Yes. Yes.
Okay.
Yes.
Then once you've done everything, then we will go to the ducting. So ducting, we will study what is laminar flow, what is turbulent flow, what is Reynolds number, what is ASTRAE design criteria, type of pressures, duct pressure, shapes, duct accessories. Then we will do the pressure drop calculations.
Yeah.
Okay. So these
Okay.
are all the things we will cover in AC and ventilations. Okay. Similarly, I have another chapter for smoke ventilation system design, and also I have another syllabus for chilled water ventilation system. But always I prefer to start with AC and ventilation so that you can able to go through other calculations. Okay, so
Okay. Yeah.
this is the syllabus we cover in the AC and ventilation system design. Clear?
Okay. Clear. Clear.